Hi, this is Ashok Kumar Bandla. In this video, I am going to present performance characteristics of an instrument. Coming to performance characteristics, we have two types of characteristics. One is static characteristics and other one is dynamic characteristics. So first of all, what is meant by performance characteristics? Selecting the proper instrument for a particular type of measurement needs the knowledge of the performance characteristics of an instrument. That means performance characteristics gives the information about how the particular instrument can be working under different conditions, under different load conditions. So in these performance characteristics, we have two types basically. One is static characteristics and other one is dynamic characteristics. In this video, we are going to see only static characteristics. Coming to the definition of static characteristics, the set of criteria defined for the instruments which are used to measure the quantities that are mostly constant with respect to time is called static characteristics. So I can say static characteristics are mostly constant with respect to time. The name static implies constant with respect to time. That's why we can call them as static characteristics. Even I have given here constant with respect to time. Now coming to dynamic characteristics. Dynamic characteristics varying with respect to time, if we observe. The set of criteria defined based on some differential equations. What are meant by these differential equations means few parameters which can change with respect to time. Those parameters can be expressed in differential equations. So the set of criteria which are varying with respect to time are called dynamic characteristics. Before going for in detail explanation of static characteristics, let us see what is meant by calibration. Calibration is the process of making an adjustment or making a scale so that the readings of an instrument agree with accepted standard value. If you have any calibrated instrument is there, depends on that values of particular instrument, we can compare other instruments values. So in that way, we go for calibration process. Now coming to static characteristics explanation, we have total 16 static characteristics which can explain the performance of an instrument. We'll see one by one. First one is accuracy. The name itself implies accuracy means the output will be more accurate, exact value. So how can we define accuracy? The ratio of the difference between measured value and true value to the true value. What is meant by true value? True value is nothing but one predefined standard value. For any instrument, we have one predefined standard value. So if you use that particular instrument, whatever the value we are getting at that time, measured value, that is called measured value. So we can take the difference between measured value and true value and take the different ratio measured value minus and the true value to the true value. If you see the formula here, accuracy equal to measured value difference true value by true value. For example, if you see one example I have shown, this is the target point where I have, if I hit the target here, I can have more accuracy. If I hit the target far away from the point like this, it is having low accuracy. Now coming to next one, precision. What is meant by precision? The ability of the measuring system to reproduce the same output values among several independent measurements. So if I use any instrument, if I apply same number of inputs, I can get same output values if you take at any time. That is nothing but precision. See here, I have shown the examples. See, this is the target point. Here, I hit the target for 4 times. If you observe, I have 4 hit values are there. So, I hit the target for 4 times. If you observe, the distance or what where the position of the target place is nearby one for 4 times. That is nothing but it is more accurate and more precise. Why? Because precision means you have hit the target for 4 times. For all these 4 times, you hit the target at near values. That is nothing but high precision. At the same time, you hit the target approximately equal to your accurate value. Now coming to next case. Here also you hit the target for 4 times, but if you observe, you hit the target somewhat near to the target. So here I am considering this as accurate, but it is not precise. It's not precise. Now why I am telling not precise in the sense, here the distance between hitting the target is somewhat distant with each other. If you observe the first case, all 4 cases are nearby ones. But here you hit the target somewhat with distance like this. That's why I can say it is not precise. Coming to third case, you hit the target far away from your accurate point. This is your accurate point. You hit the target far away from the accurate point. But you hit the target for 4 times at nearby positions. If you observe here, the distance between this one, this one, this one, this one are very near with each other. That's why I can say it is precise but not accurate. Now finally come for last case, not accurate and not precise. Not accurate in the sense you hit the target 4 times far away from your actual target point. At the same time, you hit the target 4 times with very different values like this. The distance between these two is more different. The distance between these two is more. The distance between these two is more. So this is not accurate, not precise. This is the way we can differentiate accuracy and precision. Now coming to next one, sensitivity. Sensitivity. The ratio between change in output to change in input is called sensitivity. Here delta Q naught by delta Qi. Delta stands for change, naught stands for output, I stands for input. So sensitivity equal to delta Q naught by delta Qi. Next one coming to static error, or simply we can say error. Error equal to measured value, difference, true value. True value is predefined standard value. Coming to fifth one, threshold. It's very important term in the static characteristics. Threshold. What is meant by threshold? If the input, whatever the input we are giving to the instrument, is slowly varying from 0 onwards. Normally, we used to give the input from starting point. 0 onwards, we used to give the input to any instrument. Until unless if you apply minimum value of input, output we won't get from that instrument. That minimum value is called threshold. If the input quantity is slowly varied from 0 onwards, the output does not change until some minimum value of the input is exceeded. That minimum value of the is called threshold. So threshold is minimum value of input required to get the output. That is called threshold. Coming to next one, resolution. If a non-zero input quantity is slowly increased, output reading will not increase until some minimum change in the input takes place. Resolution can be explained while we are doing the particular process. So you are in the position, you are in this position. Until unless if you apply minimum change in input, we won't get output. That's why that is called resolution. A non-zero input quantity is slowly increased. Output reading will not increase until some minimum value of input is required. That minimum value is called resolution. Coming to next one, linearity. If you observe here linearity, this is the standard curve. This is the actual curve we are getting. Linearity is nothing but deviation of this output curve from calibrated straight line. This is actual predefined straight line. How much it is deviating if you perform the experiment for that particular instrument. That is called linearity. Percentage linearity equal to maximum deviation of the output from idealized straight line. This is called idealized straight line by full scale deflection. Coming to next one, zero drift. The deviation of the instrument's output with respect to time from its zero value when the variable to be measured is constant. For example, if you want to measure any output, if you have any deviation in that instrument, that deviation is called zero drift. This causes a constant error that exists over a full range of measurement of the instrument. That particular error will carry over throughout the full range of the instrument. Coming to reproducibility. The ability of an instrument to reproduce same output values. Reproduce same output values for the same inputs applied over a period of time. If you apply same output values, we should get same. If we apply same input values, we should get same outputs for any number of times. That is nothing but reproducibility. Coming to stability. Stability is nothing but the ability of an instrument to have same standard performance over a long period of time. For example, if you are using any instrument for 5 years or 10 years or even for long period of time, that instrument should perform same set of performance even if you use that instrument for several number of years. That is nothing but stability. Coming to tolerance. Tolerance is nothing but maximum allowable error. A maximum allowable error in the measurement is specified as tolerance. For example, my actual value I should get is, for example, 10 volts. But if I got 10.1 volt, So 0.1 volt is nothing but tolerance value. That I can say like that. Coming to range or span. Range. Normally we used to call what is the range of voltmeter, what is the range of ammeter, like that. The minimum and the maximum values of a quantity for which an instrument is designed to measure is called range or span. Coming to next one, hysteresis. All of you know hysteresis curve. If you take the readings first from like this, starting to, if you take the experiment or output readings like this in this direction, and if you take back the readings once again in this direction, we won't get same values as before. For example, at this point, if I apply 10 volts, if I apply 10 volts of voltage, if I get the value of current equal to 5 amperes in this direction, forward direction, like this. The same 10 volts, if you apply in reverse direction, I won't get 5 amperes. Maybe I may get 4 amperes or 3 amperes, or it may be 5.5 amperes also. That deviation is called hysteresis. Coming to next one, dead space or dead zone. It is defined as largest variation in the values of the input for which the instrument cannot respond to produces no output. That is called dead zone. Coming to next one, span drift. If there exists a proportional change, in indication all along the upward scale, then the drift from nominal characteristics is called span drift or sensitivity drift. Come for last one. The constant error which exists over a full range of measurement is of an instrument is called bias. A constant error which exists over a full range of measurement of an instrument is called bias. Such bias can be completely eliminated by calibration. Already we have discussed what is meant by calibration. So these are the different types of static characteristics. Thank you.